In this video, we are talking about how to factor a trinomial when a is equal to 1. So we'll talk about what that means in just a moment. Let's go into presentation mode. Okay, so first you have to think about this right here, standard form. So a is the coefficient of the x squared term, b is the coefficient of the x term, and then c is the constant. So when this number is 1, when a is 1, like it is here, then you can use this method. So we'll go over other methods when a is not equal to 1. So what you do is you draw an x, okay? We got an x here. And then you're going to put your c term, whatever number's here, you're going to put that in the top, and then you're going to put your b term down in the bottom. And then you're looking for two numbers. You're looking for two numbers that are a product, that have a product of whatever the c value is, and a sum. So when you add them, they are this number, and then when you multiply them, they're this number. So for this problem, it would look like this. We'd have a positive 12 up here and a 7 down here. And we're looking for a product, two numbers that multiply to 12, but then add up to 7. So let's think about the numbers you can multiply to get to 12. 1 and 12. But 1 plus 12 is 13, right? So that's not it. Okay, and then I've got 2 times 6. Well, 2 times 6 is 12, but when I add it together, 6 plus 2 is 8, and that's not what I was looking for. I'm looking for 7. Okay, so what is 3 times 4? Oh, when I add those together, I get 7. So therefore, this solves my problem. This solves my puzzle. I put a 3 here and a 4 there. It does not matter. You could have put a 4 here and then a 3 here. It doesn't matter. But that is how I figure out what my two factors are. Okay, so I'm saying that this is the product and these are the factors. It's like the reverse of foiling. Okay, and we're going to use 3 and 4, and they're both positive, so we put pluses there. And that's it. You factored it. If you're not sure, if you're like, hey, did I really do that right? You could FOIL this. X times x is x squared. Outer times outer, so plus 4x. Inner times inner, plus 3x. Last times last, plus 12. And yes, that comes together to go right back to the problem that you originally started with. Okay, so you did it right, and this is your answer. This is your factors. Okay, now we'll go to the next slide, if I can get it to do that. Okay. All right, so we're going to do it again. We're going to put 24 goes up here and 10 goes down there, okay? Always the C term goes in here and the B term goes in there. Now, what are numbers that multiply to 24? 1 and 24, but when I add those, I get 25. That's not what I'm looking for. I'm looking for 10. Okay, so I've got 2 and 12. 2 plus 12, that's going to be 14. Not what I'm looking for. 3 and 8. 3 plus 8 is 11. So that's not it, but I was close. 4 times 6. 4 times 6 is 24, and 4 plus 6 is 10. There you go. That's the pair. So I put 4 and 6, and again, it doesn't matter which side you use. And so now I know to use for my two binomials a positive 4 and a positive 6. Since they're positive, I'm going to put pluses in there. Okay, pretty simple, right? Okay, come over here. You've got your X box. You're going to put 5 up here and 6 down there. So I'm multiplying to get 5. Well, there's not a lot of things that you can multiply to get 5. 1 times 5. 1 times 5 equals 5, but when I add those two numbers together, they do equal 6. Ding, ding, ding. I'm going to use those. And so the product is 5. So we're looking for two sets of numbers. 1 and 5 have a product. When you multiply them, it's 5. But when you add them, a sum, it's 6. Okay. And x, and 1 and 5. And they're both positive, so I put pluses here. Okay, that won't always be the case. Maybe on the next slide, we'll see something different. Okay. So here I want a product of 1 and a sum of 2. Okay, there's not a lot of things that multiply to get 1. 1 times 1. So that's what it has to be, right? 1 times 1. When I add those together, I get 2. So now I'm going to write my factors. So I have x and x, and it was a positive 1 both times. Okay, now look at this. There's another way to write that, which would be x plus 1 and then put a square outside of it. So know that these are both your answer, and it could be written either way. Okay, finally something different. Now I have a negative 18. Always my terms have been positive so far, but now I've got negative 18 and a positive 3. When you have a product, answer to multiplication, that's negative, one of these is going to have to be negative. Now, they can't both be negative, right? Because you have to have one positive, one negative to get a negative number. So I'm thinking of what multiplies to get 18, and then after I come up with my factors, then I'm going to worry about which one could be positive, which one could be negative. So I got 1 and 18, right? And then I've got 2 and 9, and I got 3 and 6. So this time I'm looking for a sum, but and remember, this could be negative 1, or it could be positive 1 and negative 18, okay? So if I add that together, I get a positive 17. That's not what I'm looking for. This, I get a negative 17, not what I'm looking for. Okay, if I made this one negative, then that would give me 7, not what I'm looking for. Remember, I'm looking for 3. Or you could do 2 times a negative 9, and that's going to give you a negative 7. So I'm just pointing out to you, like, one of these numbers is going to have to be negative. Okay, now I want a positive 3. So here we go. This is going to give me the set that I need. But should it be negative 3 and 6, or should it be positive 3 and negative 6? Got to look at what you want. You want a positive number, so that means the bigger number has to be positive. So negative 3 and 6. And now when I go to write my factors, I'm going to have negative 3, but positive 6. Okay? All right. So on and so forth. You keep going. Now, you might come up to numbers that you don't know as well, and there is something that you can use on Desmos to help you find those factors, but you should watch the other video for that. I know my multiplication tables well enough to know what two numbers are that multiply to get 63. It's obviously not going to be 1 and 63, right? Because we need 63 to be our product, but we need negative 2 to be the sum. So when we add the two numbers up, they have to equal negative 2. So it's got to be two numbers that are pretty close together, right? Okay, so 7 and 9. I guess you could have thought of 21 and 3, right? 21 and 3 would have worked as far as multiplying to get 63. But that's not your answer, right? Because the difference between them is more than 2. But 7 and 9 are. Now, which one should be positive and which one should be negative? I know I need 7 and I need 9, but I want to have a total of negative 2. So hopefully you're seeing that has to be a negative 9 to get that total of negative 2. So I'm adding these to get the bottom number, and I'm multiplying these to get the top number. Okay, so then I would write my factors, and I would say, and it could be in either order. It could be x minus 9 here and x plus 7 there, or vice versa. No problem there. Okay. Then sometimes there's weird problems. So what? There is no B term here. So you put the C term in there, and then what should you use for the B term? There's not one. Are you going to put none? No, you just put 0. Okay? Because they think about it, when you're foiling something and you have a special product then you are going to have these two cancel out. So that's a little clue when you have a 0 down here that it's going to be a special product. So you're going to use, well, what two numbers are the same number, right? And they have to total up to 16. One's going to be positive, one's going to be negative. And I'm going to have to pause this and tend to my child. Okay, two last weird type of problems. So if you're doing this problem here and you're looking for, okay, I need 8 is going to be my product and 2 is my sum. So I've got 1 and 8. Well, that adds up to 9. Yeah, or I could have had both of these being negative and that would equal -9. That doesn't help. How about 2 and 4? If I add those together, I get 6, but I want 2. Okay, well, if I have one of these being negative, then I could get 2. But can you make one of these negative? Say we made this one negative. -2 times 4 is going to give us -8. Are we looking for -8? No. So in this case, there are no numbers that are going to work for this. This is called prime. Prime. So when there are no numbers that will multiply. Now don't go thinking just because you haven't found the numbers that all the problems are prime. Okay, they're not. You're probably just don't know what you're doing yet. And you need to, try a little bit more. But occasionally you will find a problem that's like this. It's not that it's not factorable, because you can always use the quadratic formula on it, but more on that later. Okay, and then finally this last one here, it's got these weird variables, but it doesn't matter in regards to the numbers you're looking for. So I'm still looking for something that is a product. The product is 42, but when you add them up, it's 13. Okay, so hopefully it wouldn't take you too long to figure out that 6 times 7 equals 42. And when you add those together, you get 13. So I do 6 and 7. And then this is just a little bit odd. We have these extra variables. So when you go to write your factors, you've already been doing this x in the front all the time. Now you're just going to change one little thing. So when you multiply these two numbers to each other, you're going to want to get a y squared. So that should tell you that one of them is going to be 6y and one of them is going to be 7y. Then these are both positive, and that is the end of the video.